The functional test for dummies session. So just as in all sessions, some introduction about myself. I'm still Nicole, I'm still from Berlin, working in the community since 2011, being a core and security member since 2012, 2013. And as you maybe know, I'm contributing to multiple public extensions as well as supporting quite a lot own ones. And if you have any questions, you can always reach me in Slack or Twitter with the same nickname. And of course, you can always write some mails or get in contact with me on any channel. So about the session today, it's about functional testing. As I said in my lightning talk, I had the unit testing session on Friday, and I'm working with the same extensions, just another kind of testing now. And I want to repeat the basics and tell what functional testing is and stuff like this. And if you have any questions about something I say, just raise your hand, and I'm fine with answering, of course. So why do you need functional testing when you're doing unit tests? Functional testing is about test a part of your software. It's not about testing some specific function in your code, but testing a workflow. It's defined from a user's point of view, so you're testing something where you're giving some input, make some expectations, and testing if these expectations are fulfilled by your code. And of course, like every testing method, it's for quality assurance. As I said, unit testing is about testing a specific function, some specific lines of your code in your extension. And functional testing is about dealing with your database, doing multiple function calls in one of your processes. You can, as well as any other kind of testing, you could do it manually, but it's very slow, very cumbersome, and it takes you a lot of time. And I think you wouldn't do it on every change of your code, so it's more or less not a continuous testing when you do it manually. And in my session later, I will show you how you can do all your tests on a continuous integration service called Travis. So you don't have to do it on your local machine, but you can. Well, you can just say some other third-party service should run your test and check your code. So first, like I did in my other session, I want to specify some terms I'm using in the sessions, and we are all using in terms of testing. It's we do not speak of test classes, or we do not speak of classes in our test framework. We speak of test cases, and each test case can have multiple tests, of course, and you can define multiple assertions in one of your tests. So maybe you don't have, maybe you don't want to test one specific assertion, but maybe you want to check if there are multiple assertions in your test, like saying, okay, when I create this object, make sure it's in the database, and make sure it's in the database with the expected values as well. So these are assertions of a test. Just a few words for the functional test process. It's like we did for the unit testing, we're using PHP unit for functional testing. And when we run functional tests, PHP unit will find all test files or test cases in our path we defined. And like in the unit testing, each test is called step by step. So it's just one test called, everything when is tearing down, and another test is called. So each test is in a new, freshly created environment. And for the unit testing stuff, this is quite simple. For the functional testing, it's more complicated, what is done in the background by the TYPO3 framework for us. And just list up what is done for you in the background is created functional test folder in TYPO3 temp. In this functional test folder, the core is linked. And you have to define some extensions when you want to test extensions. So these extensions are linked as well to the correct place. And the local configuration is written automatically. A package stage PHP is written automatically. And the bootstrap of this instance, of this test instance, is initialized. It makes sure you have a working database connection, and the primary database scheme is imported as well. So when you're starting executing your test, you can be sure you have a working database connection, and an own instance of the TYPO3 installation is initialized. And this is done for each test, by the way. So each test gets its own instance and its own database, so you can be really sure to have no side effects from other tests, leaving data in the database or stuff like this. Well, the life cycle of a functional test is basically the same as in unit testing. It's creating an object of the test case it's running, or the PHP unit framework is executing. It's calling the setup method to initialize your current testing framework. It's calling one test of your test case, and it's tearing down, like removing some files, removing database stuff, and well, no, the temporary file is not removed, but the system gets cleared up by the framework automatically. So coming to the tester, to the hands-on part, and as I said, I'm still using my old extensions. For all of you who have not attending the unit testing session, it's about a simple blog post example. I called it X testing for showing you some meaningful tests in unit and functional testing. And the model is basically the one you already know from reading books or reading some other online tutorials. It's about a blog, having posts, having authors, texts, and comments. So this is more or less the thing you already know. And what I want to show you right now is, well, how to run your tests, of course. When you want to start writing functional tests, of course, you want to execute those functional tests. And let's just have an overview what you have to do to run them. It's about, like in the unit testing, clone the TYPO3 core from the Git repository, either from GitHub or from the git.typo3.org repository, because it's the same as they are mirrored. You have to call composer1 to install PHP unit and some other testing extensions or packages we are using in the core. And you have to use this cloned core for your development. So just make sure your TYPO3 source is pointing to that cloned core. And then you simply have to run the PHP unit with the functional test XML configuration file. And when you don't provide any other path, you're running the core functions and the core functional tests. And if you want to run functional tests of your extension or any other extension, you have to provide the specific path to your extensions and to your functional tests. But on using the command like this, it's very, your database gets very dirty, because for each functional test, an own database is created, and you have multiple databases lying around in your MySQL or in your database server. So the next thing I want to show, or I just want to simply explain, is how you can use another database connection for your functional tests, because it's better to have those test databases outside from your real database connection. So the simple part is for Unix. You can just create a temp folder. You have to make sure your temp folder has the right access setting for your MySQL user. So just make sure it's belonging to the MySQL user and group, and change your folder permissions. And then you can simply call the MySQL dsave executable and say, okay, let's create another environment for MySQL server on another port with another socket and pointing to that test directory you just created. To be honest, I can't test this because I don't running on Unix. I'm just running on Windows, and Windows is a little bit more complicated. And after you set up the new MySQL statement, you should be able to call the functional test on that other port and be able to run those tests with another MySQL database connection. On Windows, you need some preparations before you can execute, or before you can set up another MySQL environment. You have to copy some files. You have to change the port you want to use, of course. You have to change your data directory, and you have to change the InnoDB data file directory. And on the other hand, you have to create the folders you just assigned in your configuration file. You have to copy some other files to a new destination. And finally, you will be able to call to start your new server instance. Just be aware that the server instance is starting in the foreground, so you need another command line instance to run the functional test then. Just set how to start the server and how to stop it after you executed your test. And then simply call the command with specifying the second database connection, and you're fine on running functional testing of the core or your extension. So what we're going to do now is we want to write our own first functional test for our example extension. So we're defining some expectations, we define some static requirements we have to set up, we're writing the test case for our expectation. We actually implement our test and implement our assertion, just to show you or give you an expression of how to write functional tests and what you have to think about, and doing some coding right now. So let me switch to PHP Storm right now. As you maybe already know from my unit testing session, I prepared all the code so I can easily switch in my Git repository, and after the session I will publish as well the slides, of course, as well as update the repository. It's already for the unit testing stuff on GitHub. Haven't published the functional testing yet because just want to see if everything works in my live presentation. So what we're going to do right now is we have this block repository right here, and it's a simple repository, as you should know. There isn't any own functionality inside. And so it's not worth to functional test because, as I already said in unit testing, we do not need to test core functionality in our own test. And the whole abstract repository handling of XBase is already tested by the core. So if we don't have any own code, we do not need to test the core stuff again. So the first thing we're going to do in our repository is to implement some own logic in here. Yep.
Can you switch
presentation mode? Yeah. Okay. For the presentation, I just decided to use a simple find all blocks by specific prefix. So I created a new public function, find all by title prefix, using a prefix and searching for all blocks by title, saying, okay, give me those blocks with a prefix and returning them. It's quite a simple function, but it's for showing how functional testing works. And I think it's a good example to understand the code and the tests later. So to start testing now, we have to go to our folder structure. Okay. And as you already knew from the unit testing session, we have some special part in our extension where we can define tests, and this is the tests folder. And for functional tests, we have the subfolder functional. And in the functional folder, there is the same folder structure as in the classes folder. So as you can see, our block repository is in domain repository. And now for the functional test case, it's in domain repository. And the block repository PHP is called block repository test now. And just having a look in there, of course you have to adjust the namespace to meet your folder structure, and our block repository test extends from the core functional test case delivered by the TYPO3 core, which sets up your functional test instance, as I already told you, and taking care about the PHP unit handling and stuff like this. So this is the skeleton of our block repository test. Well, as I already said, you have to define your class and you have to extend the functional test case. And to be able to test your own extension, you have to tell the core Bootstrap to use your extension and to make your files available in this test instance. So there's a protected property of the functional test case class called test extensions to load. And there you have to point to your own extension and to the folder of your extension. So we're using TYPO3 context x-testing. This is the reason why the Bootstrap then knows what extension to link in your functional tests instance and is able to call your classes and your test then in this very own functional test instance. This is a skeleton of our repository test, so let's just start filling us with some own logic. And as I said, the next step is you have to define your static requirements. In our case, we want to test the block repository, and to be able to test the block repository, we need some known data in the database. Otherwise, we can't select any block with a specific prefix. So we need some blocks in our database before running our test for the block repository. So what we're going to do right now is to create a fixture, and the core has an own functionality to import some static data. We can just use an XML file, defining a data set in there, and we're specifying the table where we want to import the data, and the data itself, it's specified as well. So for our blog example, we just need UID, PID, and the title. You can insert all the other fields here as well, but I stick to just defining the properties or the data information I really need for my tests. And I created this data set manually, but the structure is designed so you can just export any XML file via MySQL dump. So there's some parameter to say, okay, I don't want an SQL dump like an SQL, which I can import as SQL, but I want to dump my data in an XML file. And that's basically the same structure, and you can just use existing data for your functional tests. So let's see how this functional or this testing fixtures are inserted in our functional test database. Going back to the repository test, it's about defining a new setup or an own setup method, saying, okay, it's very important that the parent setup is called because the parent setup sets all the instance for our test, for our functional test. And then we say, okay, import some data set. And to be able to import our block repository data, not block repository data, but block model data, we need some pages, and we can reuse the fixtures from the core because there are some basic data available as well. It's pages, it's pages overlay, static language handling and stuff like this. So just have a look in functional fixtures of the core extension, and we're using the pages right now. And afterwards we're saying, okay, import our very own functional test fixtures for our block model. What is done actually in this method is, okay, first, of course, the instance is created. Like I said, some files and folders are linked in the TYPO3 temp directory. The database connection is set up. The default scheme of the database is imported, and afterwards some page data is inserted in our database, and our own functional fixtures are imported. So there isn't any other information in the database currently, just to give you, just to remind you on that. There isn't any information, it's just an empty database with the right database tables in there, and you have to ensure that your requirements for your functional tests are inserted by yourself. So going one step further, now we want to finally add our test logic. And for this, we set up an own test function. It's a public function, of course, because it has to be called by the PHP unit framework. And we give it a meaningful naming, so we can just, we do know by reading the naming what the actual test is in there. So the same for the unit testing function names are available for the functional test function names. So we start with a functional. We start with the name of the function we want to test. This is a find all by title function of the block repository we want to test. And now saying what is done, we're saying, okay, if we have a prefix or if we call this function with a given prefix, we want the blocks with this prefix are returned. And just to give you just to show what is in our database before calling this test is I've inserted, or the framework inserted 3 block data sets. So the first one is unit testing for dummies, the second one is functional testing for dummies, and the third one is block, what about me? And now we're going to add the test and saying, okay, I want to find all blocks with the title prefix block. And our expectation is that the third block is actually fetched from the database. So what we're going to do right now is we set up our repository. Because what a repository belongs to the XSpace framework, we can't use a new operator to make a known instance, but we have to use the object manager, as the object manager has to maybe has to resolve some injections and stuff like that. So we create a new instance of the object manager, and we say, okay, give me an instance of our block repository. And finally, just call the find all by title prefix on the repository and saying, okay, we expect that the returned blocks returned by our repository have the count of 1, because we know there's just one block in our database which has to be selected with the block prefix. If you're wondering why there's a get ID in this method, it's because XSpace is using storage PIDs, and we defined in our data set that all blocks have the PID 1, so we have to make sure in our test we're using the storage PID 1, and there's some automatical checking for the storage PID using an XSpace framework, and one of them is just to check the get ID. So I'm basically defining the get ID to be sure XSpace is using the right storage PID. Otherwise, our command wouldn't work, because if we don't provide any storage PID, we wouldn't get any result. So running this test right now, going to the command line. It's just saying, okay, I set up a known MySQL server on port 3307 with a database name and some user information for the database connection, and now I want to call my functional test of my extension. And you see there's one test with one assertion, and it's a valid assertion, and so we can be sure, okay, our function, our repository function is working as we expect. So this is, I think, a very basic example how to use functional testing, and I'm hoping you're all starting with functional testing of your repositories right now, as you know how easy it is. And the second thing I want to just show is a more complex example for functional testing. It's about testing the block controller functionality. So the first thing is the same as in the repository test. We have to make sure our test case is available, so having the block controller test in here is saying, okay, my extension is my test extension as well. And if you like, you can see there's the same code as in the block repository test. So I would recommend to create some own functional test case for your extension, where you define the properties for the text extensions to load. Because for your extension, it's basically the same extensions to load in every test case. And maybe you want to define the setup method on your own or in this functional test case of your extension as well, because you maybe need the fixture data or the static data in your database for all of your tests. So it would just help to clean up your test cases a bit. But now, just let me tell you what to test. We're going to test the block controller, and we want to test some functionality we can actually test, because the list action is nothing you can test in functional tests. So I would recommend to test the list action and with some acceptance tests in your browser. So I created a test for the create action, saying, okay, if I give you this block, please insert it in the database, and I want to be sure it's in the database after the create action was called. To be honest, this test was a little bit well, complicated to create, because there were quite a few dependencies in this test. As you can see, we have this add_flash method, and just going in this method, we can see, okay, there are really some strange dependencies, so we have to need a controller context, we have to get a flash message queue, so there has to be some session handling and stuff like this. This was really complicated for me to get in touch with, because normally I don't use flash messages, to be honest. And another big problem was this redirect method, because on redirection there's an exception thrown catching by the framework and make sure, okay, you really redirect to another page. And before redirecting, the persistent manager just then stores all its information in the database. So it was basically, okay, I can't do this redirect call in my functional test, so I have to say, okay, in this method, there happens something which I don't know, but it leads to the persistence of my data information. So going back to the test case in here, and say, please reload. Of course, I have to check out the test. Saying, okay, first, I don't need my picture data in here. I just want to import the page information of the core to have some valid pages where my block can be stored on. Then I want to say, okay, I create a new block object, set some title and given it some description. And then I have to set up the block controller instance itself. And as I told you, this was a bit more complicated. So one side note for this, coming from the unit testing session on Friday, we introduced some own logic in the constructor. I hope you don't mind it, but as I'm working in the same repository, I just went on with my code from this first version of the unit testing session. So we have created an own dependencies to the environment service and made it as constructor injection. So of course we have to take care about this constructor injection in our functional test case as well. So the first dependency we have to resolve is the environment service, and we simply create a new instance of the environment service to be able to insert it in our block controller mock of the constructor arguments. So what we're basically saying here is, okay, we need some instance of our block controller, and we don't want to behave the instance like a real object of the block controller would do, because we don't need the flash functionality and we don't need this redirect functionality, because we can't test any redirects in our functional test, of course. So what we basically do here is to say, okay, we need a kind of mock. It's an incomplete object knowing all its functionality, but by default, all the functionalities are returning null. So calling any function on this object would mean, okay, there isn't any execution of the function, but just returning null. Because of course we want to test the create action of this object, we have to make sure it's not returning null, but it's actually calling this action, and the functionality of this action is available for our test case here. But what we wanted to say in this instance, say, okay, we do not need the add flashes matches, and we do not need the redirect message. So anytime you're calling add flash message on this object would mean it's basically doing nothing. It's knowing the method, so we don't get any exception. The add flash message function is called on an object and is not known by this object, but we just make sure any other code of this message of the function isn't called. And the same for the redirect thing, because as I said, we can't test the redirect anyway. Then we have to set the constructor arguments. We have the options to say either skip the construct method of this object or this class completely, or we taking care of the constructor and injecting the right arguments in there. And I decided to not skip the constructor, but to make sure the constructor arguments are valid. And finally, just say, okay, give me an instance of this defined mock, and working on this instance now. As I told you, in this redirect method, there's some functionality saying to the persistence manager, okay, just save your data, and then doing the redirect to another URL. So what I basically defined for this redirect method is, okay, when this method is called, just create an instance of the persistent manager and call persist all on them, because I know somewhere inside this redirect logic there is a call anyway, and I don't need this whole functionality, but just make sure my data is saved to the database after my action was called. So I'm just saying here, okay, I expect the method redirect to be called once in this functional test case, or in this test. And if this method is called, just create a new instance of the persistence manager and let's persist all data in there. The next step, the thing we need, is our block repository, of course, because we want to test the real functionality of the create action, and we want to make sure that the block repository is working correctly. So we set up a known instance of our block repository with the object manager as well, and we have to make sure that the instance is used by our block controller. So we have to make sure it's injected in the right property. And as our controller doesn't have any inject block repository method, and the property block repository of the block controller is protected, we have to use some magic function of the functional test framework of TYPO3 to make sure our instance of the block repository is used. And this is done by this inject. We're saying, okay, where want we inject any object, in which property do we want to inject, and what are we going to inject in this into this object. So what it's done, basically in here, there's some kind of reflection testing and making protected properties public to be able to inject the object at the end. And just don't care about that, that's working, and you can use it in your functional test if you have to inject or use some protected property without any set or inject method in this class. And finally, we are able to call our create action and to check if our object, our block object, is stored in the database. And at the end of the test, of course, we have to make some assertion to say, or to be able to tell, okay, did the call from this action worked finally? So the main part of this assertion is, okay, let's fetch some data from the database and assert that there is an object inserted. So what I'm doing here is calling database select rows on the database connection and saying, okay, please select all blocks with the given name I have in there. It's the same name as my block object had, of course. And then I'm saying, okay, I expect that the count equals 1 because I finally inserted one object in my create action. And running those tests again, saying we executed 2 tests, namely our block controller test and our repository test, and everything, all our assertions are working right now. Yes? Huh? Yeah. Let me just go. So running the test again, just to see it a bit better. Now we have 2 test cases with 2 tests and 3 assertions. 3 assertions because we defined our block controller expects some method to be called. So this is one assertion as well. And the other one is saying, okay, I'm asserting that the count on my database equals 1 to be sure there's a new block in there. So I just wanted to show you some other stuff I did on the block example, the block controller stuff, just to show how complicated it might be to set up an environment when you don't decouple your objects in your test. So let's see if this applies. So when I started with writing the functional test for the create action, I was like, okay, there's a redirect method, and somewhere in this redirect method, I know there's a persistence manager call to store its data into the database. So maybe it's not enough to call my create action, but I have maybe to call the process request action to be able to use this redirect stuff and make sure the database, to make sure the data is persisted in its database. So what I was trying first was to say, okay, I have a request instance and a response instance and set up some information about my test case in here and just calling block controller process request with those object. Finally, I came to the conclusion, okay, this doesn't work, unfortunately, because in this redirect method, there's some magical stuff happens, some URL generation based on the current request, and I was not able to use this redirect function in CLE context for the functional test. So what I did basically is like you already shown, I defined, okay, somewhere in this redirect method, there is some persistence call and I just want to fake it. I just want to decouple the functionality of persisting data in my test just to be able to run this test and, well, I don't need this redirect functionality. So while writing tests, you have to make sure your test or your objects or your workflow you want to test is really testable. And you have to make sure to make a decoupling from other objects or from other requirements by just saying, okay, this is a defined method and just use it. Don't worry where it's called anywhere. So what I basically did, like you see, it's okay. I'd say somewhere in this method redirect there is a storing of data. So simply fake this this method call and well, just stop after create action was called, so be able to check this. And the good thing is, when going back to the original code right now, when some other one is testing your code and is changing your code, and maybe it is changing the redirect of the redirect method call in your block controller, there's a test saying, okay, I expect this call because otherwise I don't know where this persistent stuff is done. So this test will break without the redirect call. And then you can, either you have to redefine the, your functional test to be in line with the current changed code, or you have to change your code and saying, okay, but after the object was added to the repository, we have to call the redirect to be able to store the data and go somewhere else. So it's a kind of making sure your code doesn't break even if anybody else is working on your extension. So this is basically the functional testing workshop right now. What I want to go a step further is showing how you can run your functional tests not on your own environment, but on some third-party service called Travis, where you can be sure, okay, each time something changes, a test is triggered, and even if you forget to run your test manually on your laptop, there is some destination telling you, okay, it's valid or it breaks your functionality and you have to rework over your code. So who of you is using Travis actually? Not that many, okay. Who of you is writing extensions? Okay. Who of you is using functional testing yet? Kind of, okay. So, who is going to use it after my session? So, just going one step further here. The first need you have to do is use GitHub. And as we already heard in the keynote, we recommend to move your extension code to GitHub anyway, so that shouldn't be any problem right now. But the service Travis is bounded to GitHub as there's some internal connection between GitHub and Travis. And to be able to run functional tests in any case automatically is create a composer JSON and use composer to set up a defined environment. And you have to tell in a so-called .travis YAML file what the service actually has to do. The good thing is you can copy those files from project to project. So what I'm going to do right now is switching the branch again and saying, okay, the first thing I've defined is the composer JSON, giving some name, some description, some keywords, link to your homepage, and very important is the type of your extension. It's called TYPO3-CMS-extension, just to be able to recognize your extension as TYPO3 extension, and when you do composer install, there's some magic TYPO3 installer moving all those TYPO3 extensions to the correct place. And of course, you have to set up your requirement to TYPO3 CMS. So I say my extension is valid with a 7.6 instance as well as a current 8.3 version. And I'm using PHP unit as testing framework, so I have to require this as develop dependency in my code on my own. Giving some auto-load information about my class names and the folders where my classes are stored. Finally, you have to make sure you insert a valid piece for namespace for the TYPO3 core tests on your own, because you're using or you're referring to those test classes in there, and otherwise Composer wouldn't load those information for you. You have to do some replacing stuff to be, well, to get a valid Composer JSON for TYPO3 projects. And finally, you have to insert some post-autoload dump script. What's basically done in here is it's creating a folder, a test instance for this environment in .build folder, and linking your current extension to that folder, because that folder is used in the Travis test afterwards. So this is, I think maybe you think this is kind of complicated, but in fact you just have to copy and paste this Composer JSON, leaving all the scripts and extra information like it is. Just have to make sure the correct extension key is used in there and the autoload information are valid and your name is changed. But basically the other code in the Composer JSON is just leave it like it is. And having a look at the .travis YAML, it's basically the same, just copy and paste it from any other project and simply adjust it to your needs. So what we are going to define here is which PHP version and which TYPO3 branch are we going to check for our extension. As I said, I decided my extension is able to run on TYPO3 7.8 until TYPO3 8.3. So what I defined basically here is, okay, 7.6 is supporting PHP version 5.5, 5.6, 7, and 7.1 if it actually is released. So I want to make sure my extension tests are executed for each of those instance combination. And saying or declaring the same for the 8 branch of TYPO3, it's PHP 7 and PHP 7.1. And I even want to check the current master, because I want to make sure in a new version of the TYPO3 core there isn't any change which breaks my code actually. So I'm testing the current develop master of the TYPO3 core as well with PHP 7 and PHP 7.1. And there is some stuff doing to set up the instance in this Travis box. And finally, it's just called, okay, running unit test if you find unit test, running functional test when you find functional test, and finally just do some linting. And as I said, this file can be copied and pasted from project to project as well. You just have to define your metrics, so the versions and PHP versions and TYPO3 versions you want to check for this test. And going to Travis, just want to show you the results you're seeing in there. What's basically done, you can see there's some tests for PHP 7.1 with current master TYPO3, and going in there you can see, okay, there's a container or virtual box set up, but it actually runs my test then, and it's running the unit test, it's running the functional test, and it's doing some linting stuff. And as you can see, with this combination of PHP version and TYPO3 core version, this test is passed. And so you can see there are actually now 8 tests in own instances checking my code, my functionality is not breaking in any version or any versions combination. So each time you're pushing some new code to your GitHub projects, then the Travis gets notified from the GitHub automatically and runs those defined tests within your test in your extent or from your extension. So, coming to the end right now, and I don't know if there are any questions. Don't think so. Okay, yeah.
What about private extensions? Do you have a recommendation to do that? Because you can do it also with private GitHub and private Travis, but at least I think it's a bit expensive. Do you have any recommendations?
So the question was about private extensions. Well, I can recommend to set up an own continuous integration system for your private extensions. We set up a Jenkins version for that and just doing the same things on Travis, but without virtualizing, but running tests on each pull request. So it's, if you have private repositories, you have to use private services for that. I know there are private GitHub repositories. Those can be used with the Travis service as well. But if you have unpublic private extensions for your company or something like that, you have to make sure there's an own workflow executing the tests.
We have a CI server based on GitLab, but we don't have this nice version matrix in PHP in 3. We didn't find a way yet to do such a nice matrix.
Okay, so basically you stick to one PHP version and one TYPO3 version, okay. Well, I haven't any solution for that yet because we're using the defined projects versions as well to make sure our private extensions are working with this defined environment. Maybe some other can help in telling how to do multiple test combination. Yeah.
So if you're testing master, Travis runs when you do a push to your own extension, right?
Yes.
Do you know about any way how Travis could run, like maybe on a nightly basis, because master changes constantly, right? So could get notified when master changes and something breaks?
Yeah. No, I don't know. Maybe you have to set up some own pull request for those and saying, okay, each night I'm having cron job, just doing a commit amend to that branch and force pushing that branch to this pull request, and then you have nightly build of your extensions with the current branch. So the question was, what about having the master check for this extension, or be able to run the checks on master while the master was changed? Because now it is like that. The tests are only executed if I change my extensions and pushing some new information to the repository, but it's not called nightly or in any defined period for the master branch. Any other question? So as I told you, I will push the slides to SlideShare and update the repository so you can find the example in a code-wise and a slide-wise way. And if you have any questions afterwards, just come to Slack and give me some note you need help. So just contact me. Thank you.